Hi, this is going to be Chapter 11, Sensation and Perception for my Psych 105 final project. And my name is Saavedra, and let's begin. Hi everyone, and welcome to the short presentation of Sensation and Perception. Today we will explore how our brains and bodies work together to process the vast amount of information that we take in every second through sight, sound, taste, and smell. This content is based on the Nova Psychological chapter by Adam John Perverta, and it offers a fascinating look into the science of how we experience the world. As you can see by the picture, we have the sensory stimuli and the sensory receptors. Sensation and perception may sound similar, but they refer to different processes. Sensation is the raw data, light hitting your retina or vibrations in your ear. Perception is what your brain does with the data, like recognizing a red light at a stop sign or a stop signal. The sensory organs send that information to the brain, but perception is where meaning is added. The distinction is key in psychological and neuroscience. What is sensation and perception? Sensation, the physical processing of environmental stimuli by the sense of organs. Perception, the psychological process of interpreting sensory information. And as you can see, the woman in the picture is listening to music through her headphones, so she is listening with her ears and understanding the vibrations. Our 5 traditional senses: vision, hearing, taste, smell, and touch, are all specialized to detect different types of energy or chemicals. The eyes detect light, the ears detect pressure waves in the air, and taste and smell respond to chemical stimuli. For example, if you're smelling an apple pie, you're going to get a whiff of that beautiful smell and get hungry, but you're smelling it. Or taste, you go and taste that apple pie. That's a chemical stimuli. Touch detects pressure, temperature, and pain. Although these are the main senses we often talk about, researchers are now identifying more, such as proprioception, the sense of body position and balance. And as you can see in the image, we have sight, hearing, smell, taste, and touch. Our senses have limits. The absolute threshold refers to the minimum stimulus intensity needed for detection. For example, how dim can light be before it becomes invisible? The difference threshold, or just noticeable difference, is how small of a change can be before it is noticed. Like adjusting the volume slightly with your headphones, these thresholds aren't fixed. They can change with age, attention, and context. And as you can see on the slide, absolute threshold, the minimum intensity of stimulus that one can detect 50% of the time. An example of this would be the faintest sound a person can hear in a quiet environment, and you can see that in the picture, the lady is trying to hear. All sensory systems depend on transduction. This is the process of turning physical energy, like sound waves or chemical molecules, into electrical signals that the brain can understand. For example, in your eyes, photoreceptor cells in the retina can transduce light into electrical activity. Without this conversion, our brain would be able to interpret the outside world. It is the bridge between physical reality and conscious experience. Now, in the slide, you could see the example. The photoreceptors in the eyes convert light energy into neural signals. You can see, I believe that is a pie, the sight of a golden brown pie, hearing the crunch, the touch, the sweet taste, and then the smell. And at the bottom, you see transduction. Transduction is the conversion of physical stimuli into electrical signals in the nervous system. Perception isn't always perfect. The brain sometimes fills the gaps or makes errors, which can lead to illusions or misinterpretations of reality. Perception is not always accurate. For example, an optical illusion could mix up the perception of what you are seeing or misheard lyrics of a song, which would be called the Mauding effect. And on the right side, you could see an optical illusion. Your senses often work together, which when you watch someone speak or your brain blends visual and auditory cues to understand them more clearly, a process called multisensory integration. The brain combines information from multiple senses to obtain better accuracy. Now this is more explained on this slide. Our senses don't work in isolation. The brain constantly merges sensory information to create a more accurate perception. A common example is the McGurk effect, where visual cues from lip movements can change somehow we hear misspoken sounds. It's a powerful demonstration of how we can rely on multiple senses working together to interpret our environment. And as you can see, they are watching and hearing a movie, which involves both visual and auditory information, enhancing the experience. Why does this all matter? Sensation and perception matter a lot in our daily life, and we might not even realize it. It's basically one of our daily tasks that we would not even remember that we do. This could be seen in marketing for multiple product designs when companies want to get the customer's attention. More real-world applications: design, crafting user-friendly interfaces that align with human sensory processing; safety, developing warning systems that effectively alert multiple senses; healthcare, assisting patients with sensory processing disorders. Understanding sensation and perception help us improve many aspects of life. In product design, knowing how people perceive touch and color makes interfaces more intuitive. In healthcare, therapies for sensory processing disorders are based on this research, and in education, safeties that combine visual and auditory learn more effective. These fields all benefit from applying what we all know about senses and perceive. In conclusion, sensation and perception are fundamental to how we experience the world. They involve complex processes that translate physical stimuli into meaningful daily experiences. Further study can lead to advancement in technology, healthcare, and understanding human behavior. To wrap up, sensation and perception are at the core of how we interact with the world. From detecting smell to recognizing a friend's voice, these systems shape every moment of our lives. The brain is not just a passive receiver of data, it is actively constructing our experience of reality. By studying these processes, we not only understand better ourselves, but we also improve how we design, communicate, and care for others.